To a new video for Algebra 2. In this video, we're going to be discussing hyperbolas. So let's go ahead and dive in. So we're going to be using Pythagorean theorem in hyperbolas, and we'll see later on how this theory or how this math equation will be useful for us. So this is the standard equation for a hyperbola if your center is 0, 0 at the point of origin. So there's no h and there's no k to translate the formula up, down, or left, right. Later on, I'll show you how adding an hk or moving the center of the hyperbola off the point of origin will affect it. So again, what we're working with is just the basics right now. We're just looking at the hyperbola equation, which is this. Now, this particular equation, you'll notice that that much like our ellipse, our a will be on the main axis. Okay, so that's our x squared over a squared minus, instead of plus, minus y squared over b squared equals 1. So with this particular form of the equation where your x is first, where your main axis is on the x-axis, this is what that graph is going to look like. The standard graph looks like this, where I have our dotted red line. Let's focus on that first. Our dotted red line are asymptotes. Okay, and those asymptotes are found by using this equation right here on the top. Y equals negative b over ax. That's your slope-intercept form. So the b over a is actually your m. That's your rise over your run. So you use your b and your a. Okay, that's how you. And then you notice that it's a negative b, so it's a negative slope. So that's looking at the line going from on the top left going down. And then on the other line, starting from the bottom left going up, that's a positive slope. You have your y equals, with the positive slope, b over a times x. Okay? So you use these equations to find your asymptotes. And then, of course, you'll see where your vertices are. Your vertex, that's your a1. Okay? And then you have your negative a0. I'm sorry, I said a1. That's a0, your coordinate point. And then the other coordinate point for the other hyperbola is negative a0, because your y coordinate is 0. It's right on the x-axis. And then you'll notice your foci is c0, okay, and it's going to be just in front of that vertices. So the c, that's where you're going to use to find your c. That's where the Pythagorean theorem equation is going to come handy. So we'll see again an example of that. So let's take a look at the other form of this equation, our vertical hyperbola. You have your y squared over a squared minus x squared over b squared equals 1. And that particular graph is going to look like this. So you'll notice our hyperbola is now opening up and opening down. And our foci now is 0, see, because now it's on the y-axis. So our x coordinate is 0 on both. So that's in the green. Okay, you'll notice the one on the positive side, 0c, and then on the negative side, 0, negative c. And again, I remind you that to find the c, Pythagorean theorem equation will come in handy. And then you have your vertices, 0a, and then on the negative side, in red, 0, negative a. And again, just like before, to find your asymptotes, you're going to do y equals negative, to find the negative asymptote, negative a over b times x. If you remember in the previous graph, it's negative b over a. So now we've just flipped our terms. And then to find the other asymptote, of course, the positive one, it's y equals a over bx. Okay, and you notice that slope is a positive slope, so that equation is to find the line that's starting from the bottom left going up in a diagonal form. Okay, so let's compare the two equations. Again, here is my horizontal asymptote with the x-axis being the main axis. Okay, and then notice that the x squared over a squared at the top. Let's see what that graph looks like. And you can see on the right-hand side, I have it kind of grayed out a little bit. Let's take a look at that one, see how it's different. So you have your y squared over the a squared, which is the main on the main axis, the vertices for the main axis. Okay, so you can see how they both differ. You can see their similarities and their differences. One is on the x-axis and the other is on the y-axis, and both having our asymptotes drawn in red dotted lines. Okay, let's practice one. So I have y squared over 64 minus x squared over 49 equals 1. So luckily these will simplify pretty easily because 64 simplified would be 8 squared and 7 squared is 49. So that helps me find my a and my b. So now I know my a and b. A is 8 and b is 7. And I need these to help me first find my vertices and then find my asymptotes. Okay. Now I want to find my c also, just to have everything ready for me when I start putting my graph together. So a squared plus b squared will equal my c squared, and I know what my a and b are already. So I just got to do a little simple arithmetic. 113. I square root my c squared, and I end up with square root of 113, which does not square root evenly. It doesn't give me a clean number, so it's approximately 10.63. So now I know the value of my a, b, and my c. Now I can start putting my graph together. Okay, so this was my original equation right here. This is my standard form equation. Let's put it together now. And since, let me go back, since my y squared is the first term, then I know that it's going to be a vertical hyperbola. So this is what my graph is going to look like. So I can go back and check. All right, so I have my a. You'll notice for my vertices. I have my b term, which will help me in finding my slopes for my asymptotes. And I have my c for my foci. So I have all the components that I need to put this graph together. All right, so let's start off with our a. This is our main vertices. And my c is my foci. Okay, and now I'm going to find my asymptotes. My a and my b, that's 8 and 7. So that means I go rise over run, right? I go up 8 over 7. And now I have my 2 points for my first asymptote. And that's my positive asymptote. Okay, that's a positive slope, you'll notice, going up from bottom left to top right. Now I'm going to look for my other asymptote, which is just the opposite, right? I go down 8 over 7. And there's my negative asymptote. So I have my asymptotes, and now I can draw in my hyperbola. All right, so I can easily make a table for some x's and y's and find specific points and then draw my hyperbola, and it'll look something like that. My blue line will follow my asymptotes. They will come very, very close, but they never actually come in contact with that particular line. And that's my graph. That's how you graph hyperbolas when your point of origin or your center is at the point of origin. Okay, I hope that helps. Good luck in your studying.